and welcome back. So today we are continuing with the next topic in Unit 5, that is test strategies for conventional software. So the first testing we are doing is the unit test. That is, the module interface is tested to ensure that information properly flows into and out of the program unit under test. So unit testing focuses verification effort on the smallest unit of software design, that is the software component or module. Using the component level design description as a guide, important control paths are tested to uncover errors within the boundary of the module. Unit test focuses on the internal processing logic and data structure within the boundaries of a component. This type of testing can be conducted in parallel for multiple components. So at a time, parallelly, we can test multiple components using unit test. So here actually local data structures are examined to ensure that data stored temporarily maintains its integrity during all steps in an algorithm's execution. And here all control structures in a module are executed as at least one. That is, inside a control structure, we have number of coding lines that are executed at least once in the test. Also, the boundary conditions are tested to ensure that the module operates properly at boundaries. So this is the figure which shows the, so see, when in a module, when we are sending test cases, we are testing the interface, local data structures, boundary conditions, independent paths, and error handling paths. Now, data flow across the component interface is tested before any other testing is initiated. Selective testing of execution paths is an essential task during the unit test. That is, execution path means if there is any errors, uncover errors due to erroneous computations, incorrect comparisons, or improper control flow. All these are being tested. Now, unit test procedure. So this is the figure which shows the procedure of unit test. So here, because the component is not a standalone program, driver or stub software must be developed for each unit test. Here the figure shows the unit test environment. A driver is nothing but a main program that accepts test case data, passes such data to the component and prints results. Whereas the stubs serve to replace modules that are invoked by the component to be tested. So a stub is, sometimes we can call it as a dummy subprogram which uses the module's interface and do minimal data manipulations, prints verification of entry, and returns control to the module undergoing testing. So stubs are not actually integrated. They are dummy subprograms which may not be integrated along with the original program, but we create it in order to test the program or the software. Now, drivers and stubs represent testing overhead. That is, both are software that must be written, but that is not delivered with the final software product. Unit testing is simplified when a component with high cohesion is designed, when only one function is addressed by a component, and the number of test cases is reduced and errors can be more easily predicted and uncovered. Now we have the next testing strategy for conventional software, that is integration testing. Integration testing is a systematic technique for constructing the software architecture while at the same time conducting tests to uncover errors associated with interfacing. So here the objective is to take unit tested components. So after unit test only we are performing integration testing. So the unit tested components are taken and build a program structure that has been dictated by design. The program is constructed and tested in small increments where errors are easier to isolate and correct, interfaces are more likely to be tested completely, and a systematic test approach may be applied. So we have two types of integration testing, top-down integration and bottom-up integration. In top-down integration, here modules are integrated by moving downward through the control hierarchy, beginning with the main control module. So see, M1 is the main control module and we are moving downwards through the control hierarchy. Modules subordinate to the main control module are incorporated into the structure in either a depth first or breadth first manner. So either it goes depth wise or it goes breadth wise. So integration process is performed in a series of 5 steps. The main control module is used as a test driver and stubs are substituted for all components directly subordinate to the main control module. So we are substituting stubs and the main control module is used as the test driver. Depending on the integration approach selected, that is depth or breadth first, subordinate stubs are replaced one at a time with actual components. Tests are conducted as each component is integrated. On completion of each set of tests, another stub is replaced with a real component. Okay. Regression test may be conducted to ensure that new errors have not been introduced. So regression testing I will be discussing in this section episode itself, but in the later part. The process continues from step 2 until the entire program structure is built. After forming the structure, testing is completely done. Here there are some problems in top-down integration, that is stubs replace low-level modules at the beginning of top-down testing. Therefore, no significant data can flow upward in the program structure. So the data cannot flow upward, only that it can go downward or top-down means. So as a tester, you are left with 3 choices here. That is delay many tests until stubs are replaced with actual modules. Okay, you have to delay many of the tests since stubs means they are dummy subprograms. So until you have to delay until the stubs are replaced with the actual modules. Then develop stubs that perform limited functions that simulate the actual module, or you can integrate the software from the bottom of the hierarchy upward. So for overcoming these, we have bottom-up integration. As the name implies, begins construction and testing with atomic modules. Because components are integrated from the bottom up, the functionality provided by component subordinate to a given level is always available and the need for stubs is eliminated. So here you can see a figure. Here the components are combined to form clusters 1, 2 and 3. You can see the clusters 1, cluster 2 and cluster 3. So each of the clusters is tested using a driver. You can see D1, D2 and D3 as the drivers. Components in the cluster 1 and 2 are subordinate to MA. Drivers D1 and D2 are removed and the clusters are interfaced directly to MA. Similarly, driver D3 for cluster 3 is removed prior to integration with module MB, and both MA and MB will be ultimately integrated with component MC, and likewise it goes from bottom to the up. Now, a bottom-up integration strategy may be implemented with the following steps. Low-level components are combined into clusters that perform a specific software subfunction. A driver is written to coordinate test case input and output, and the cluster is tested. Drivers are removed and clusters are combined, moving upward in the program structure. Whatever I said now has been explained as a 4-step process. Now we have the next one, that is regression testing. In regression testing, each time a new module is added as part of integration testing, the software changes, right? So new data flow paths are established, new input-output may occur, and new control logic is invoked. So these changes may cause problems with functions that previously worked flawlessly. Because new paths and new modules have been added, it may cause problems with the functions. So here in the context of an integration test strategy, regression testing is a re-execution of some subset of tests that have already been conducted to ensure that changes have not propagated unintended side effects. So to ensure that if new module is added, we have no side effects to the software, we are performing regression testing. So here it helps to ensure that changes do not introduce unintended behavior or additional errors. Now regression testing, we are conducting it manually by re-executing a subset of all test cases or using automated capture or playback tools. So these capture or playback tools enable the software engineer to capture test cases and results for subsequent playback and comparison. So whenever we are introducing a module, we can just play back the test cases and results whenever possible. Regression test suite contains 3 different classes of test cases, a representative sample of tests that will exercise all software functions, additional tests that focus on software functions that are likely to be affected by the change, and tests that focus on the software components that have been changed. We have the next one, that is a simple testing process, that is smoke testing. Smoke testing is an integration testing approach that is commonly used when product software is developed. So it is designed as a pacing mechanism for time-critical projects, allowing the software team to assess the project on a frequent basis. So after the product is developed only, we can perform smoke testing. Okay, and the smoke testing is always performed by the software team on a frequent basis. So smoke testing approach encompasses the following activities. That is, software components that have been translated into code are integrated into a build. A build includes all data files, libraries, reusable modules, and engineered components that are required to implement one or more product functions. Then a series of tests is designed to expose errors that will keep the build from properly performing its function. The intent should be to uncover errors that have the highest likelihood of throwing the software project behind schedule. Then the build is integrated with other builds and the entire product is smoke tested daily. The integration approach may be top down or bottom up. So regression testing and smoke testing is part of integration testing. While we integrate some modules, some new modules into the older ones, we have to perform regression and smoke testing. Now, smoke testing provides a number of benefits when it is applied on complex time-critical software project. That is, integration risk is minimized, quality of the end product is improved, error diagnosis and correction are simplified, progress is easier to assess. So these are all about testing strategies for conventional software. I hope today's episode was understandable. Thank you.